Fishermen usually go at sea to catch some particular species that we call the target species. If we take the example of tuna fisheries, for instance, the target species are tunas. However, when trying to catch the target species, fishermen sometimes catch species they don't want to catch, which are called the bycatch species. In the past, fisheries management only cared about managing the stock of target species. With a new ecosystem approach to fisheries, the objective is also to manage the stocks of all species that live in the ecosystem and that are impacted by the fishing activities, which includes, of course, the bycatch species. In 2008, the European Commission has funded the research project named MADE for mitigating adverse ecological impacts of open ocean fisheries. This research project focused on two main pelagic fisheries, the tropical tuna purseine fishery and the pelagic longline fishery. The objective of this project was to develop mitigation techniques to reduce the bycatch of pelagic sharks, also the catch of some juvenile target species like swordfish or tuna. This research project gathered 8 different countries, and scientific activities were conducted in the Indian Ocean, in the Atlantic Ocean, and in the Mediterranean Sea. When you want to develop mitigation techniques, you need to know the ecology of your bycatch species. You need to understand where they go, how they behave. But you also need to understand and to know the different fishing practices and understand how the fishermen handle these bycatch species. So in this project, we have conducted many different scientific activities to better understand the ecology of pelagic sharks or juvenile swordfish. And also, we have been working with fishermen in order to understand their practices and see how we can improve these practices. The different scientific teams of the project have been using the same technique and the same protocol to investigate the behavior of pelagic animals. We have been using what we call pop-up archival tags. Let's see how these tags work. First, you need to catch individuals in a very good condition. You need them to be in a very good shape. As you can see, the technique consists of attaching the shark alongside the vessel, putting the shark on its back, so that the shark is in catalepsy and the scientist can operate the shark in a good condition in a safely way. Then we put the tag on the back of the animal. When the animal is swimming in the ocean, the tag is collecting different types of data. The tag is equipped with different sensors. We have temperature sensor, pressure sensor, and the light sensor. After a given amount of time, a given period that is fixed by the scientist, the tag detached itself from the back of the animal, comes to the surface, floats, and transmits all the recorded data through satellite to the scientist in his office. Then the scientist interprets the different data from the sensors, depth, the light sensors, and the temperature sensor, and try to reconstruct the path of the animal, the different swimming depths where the animal has been, and also the trajectories in the horizontal movement. In the first part, we will see some of the scientific activities that were conducted on the longline fisheries, and in the second part, you will see what we have been doing on the tropical tuna purseine fishery. Pelagic longlining consists of deploying a long line of several kilometers in the water. Many hooks are attached to this long line. These hooks are baited with small pelagics or squids with the objective of attracting large predators to the hooks so that the fishermen could catch usually tuna or swordfish, which are the main target species of longline fisheries. However, these hooks sometimes attract other species like sharks, rays or other finfish species. When fishermen retrieve the long line after a few hours in the water, then they discover what they have been catching. Some tuna, some swordfish, hopefully, but sometimes these unwanted species. The objective is really here to understand when you catch bycatch species or when you catch the target species. For this, we have been investigating the vertical behavior of the different species or the depth at which the different species are caught by the different hooks. The objective is really here to understand the ecology of the bycatch species, understand at what depths the hooks are deployed by the fishermen, and to examine if there are some particular practices that could be used by fishermen to avoid catching these bycatch species while maintaining a good catch of the target species. We will see now some images taken by our scientists on the field when tagging blue sharks in the Azores.
The blue shark is, in the context of pelagic sharks, a special case because it is a bycatch traditionally, but more recently it has become the interest of the industry for profit purposes as well. So in some areas it's not a bycatch species anymore, it's actually a target species. That does not mean that there aren't concerns with its sustainable exploitation and conservation, so it is also one of the target species of the project. So in the Azores, for example, what we found out was that the juveniles, so the immature blue sharks that occupy the area, actually range much wider than was previously thought. And we know this because we were able to use smaller tags recently developed by the manufacturer that allowed us to tag the smaller individuals, and we got the tags to stay long enough to know that the animals do an annual cycle that range across the whole North Atlantic basin, and then eventually they will return to the area. So, for example, the notion of a nursery area is now quite different than it was 2 years ago, thanks to this project.
Let's move now to Brazil and see what the Brazilian team has been doing on the different shark species, the oceanic white-tip shark.
Mostraram pra gente que a espécie ela é extremamente epipelágica, ela passa muito tempo na superfície. E esse resultado a gente pode utilizar para, por exemplo, no caso da pesca com espinhel, se pesca com espinhel com os anzóis numa profundidade muito rasa. Então, se nós pudermos aprofundar esses anzóis para que eles atuem numa profundidade maior, estaríamos evitando que a espécie fosse capturada.
Let's go now to the Mediterranean Sea and see how colleagues in Greece and in Italy has been doing on juvenile swordfish caught by small longline vessels. We will see now some images taken by the scientists on the field.
The Mediterranean swordfish, which is a unique stock, has a problem. The fishery catches traditionally a big number of juvenile swordfish. it was the first time that electronic tagging was made on juvenile swordfish, on small juvenile swordfish. We tagged fishes of around 10 kilos or less. We put some instrument on the commercial long lines targeting swordfish in Greece, so we can see at what time every fish was caught on the long line, and also to see at what depth and at what temperature the long line was when the fish was caught.
This new knowledge on the ecology of pelagic animals must be used now to see how they can adapt the practices to avoid catching these species.
São informações de extrema importância para a tomada de medidas que venham a proteger espécies capturadas que não são alvo dessa pescaria, como por exemplo algumas espécies de tubarões, o tubarão azul, o tubarão estrangeiro, e que com esta informação disponível nós podemos tomar medidas, por exemplo, impedir que um espinhel seja lançado numa profundidade mais rasa que capture uma maior quantidade dessas espécies de tubarões. Então, são medidas simples, mas de um resultado bastante efetivo e que poderá diminuir em consequência a quantidade de espécies capturadas de forma acidental nesse tipo de pescaria.
Longline fisheries use baits to put on their hooks to catch large pelagic animals. Usually these baits are small pelagic fish or squids. The catch of these baits represents an impact of longline fishing on the ecosystem. If fishermen could use an artificial bait, this would reduce the impacts of fishing on the ecosystem. Let's see now what has been done on the development of artificial bait in the Indian Ocean.
Il est d'une taille relativement conséquente pour agir sur la sélectivité des tailles. Donc, effectivement, comme les poissons capturent l'appât avec une certaine ouverture de bouche, la taille de ébab va permettre d'avoir un effet sélectif sur la taille des prédateurs. Il a donc une deuxième fonction, c'est que c'est un appât qui est réutilisable, là, avec une longévité donc, de l'ordre de 2 ans. Et c'est un appât donc, qui, pour son aspect attractant, a une chambre qui permet d'accueillir donc, une saucisse qui est fabriquée avec des déchets des usines de transformation. Donc ça permet aussi donc, une utilisation, un développement de sous-produits de l'activité de pêche. Les résultats tant des pêches expérimentales à la palangre, donc en utilisant des appâts naturels et en utilisant donc, les appâts artificiels, nous permettent d'espérer un impact significatif des mesures de réduction des prix accessoires auxquelles aura contribué le programme MADE pour les pêcheries palangrières.
The results from all these scientific activities done in different countries are used now to propose different mitigation techniques, from adapting the depth of the hooks to avoid catching some particular bycatch species, also to propose some areas in the ocean that could be protected to avoid large catches of bycatch, and also the use of this artificial bait that could really reduce the impact of longline fishing on the ecosystem. Let's move now to a different fishery, the tropical tuna purseine fishery, and see what the different teams of the project have been doing to reduce bycatch in this fishery. This fishery is mainly using 2 modes of fishing. They catch free swimming schools of tuna, or they also catch schools of tuna that are associated with 13 objects. Tropical tunas and other pelagic species are known to associate with natural floating objects, such as logs or natural debris. When fishermen discovered this associative behavior, they started to construct and deploy artificial floating objects called fish aggregating devices, or FADs. These FADs are usually bamboo rafts, and they attach radio or satellite devices to the raft so that they could relocate these floating objects. Nowadays, fishermen use buoys equipped with eco-sounder to estimate the amount of tuna underneath the FADs. We have been conducting different research activities on these buoys.
Bueno, nuestras últimas estimaciones sobre la cantidad de objetos que pueda haber en el Índico hablan de unos 4.000 a 5.000 objetos cada año, solo en la flota española. Bueno, los pescadores lo que hacen es ponerle una sonda al objeto para no perderlo, para saber en todo momento dónde está, y lo segundo, para tener una idea de qué cantidad de biomasa puede haber en el objeto. Pero nuestro trabajo ahora consiste en poder ayudarles a discriminar en qué tipo de pescado puede haber debajo del objeto. Para ello estamos intentando, usando datos de marcado y datos de la propia sonda, hacer un estudio simultáneo de caracterización de las capas que nos da la propia sonda, para poder así discriminar y decir capa 1, 2, 3 o lo que sea son bycatch, otras capas son capas de mezcla entre atún y bycatch y otras capas son de atún.
The main difference between the two fishing modes of tropical tuna purseners is the rate of bycatch. When fishing on free swimming schools, tuna purseners usually catch 1% of the total catch of tuna. 1% is represented by bycatch. When they fish on FADs, it's 5%, so you have 5 times more bycatch than when fishing on free swimming schools. So the objective of the project is here to investigate different methods to reduce this rate of bycatch, and in particular to see how we can avoid catching pelagic sharks. When fishermen find a FAD, they first launch the skiff and then deploy the net. And the net goes to about 200 meters depth. And the net is encircling all species that are present with the tuna. So that if you have other species around the tuna, all these species are caught by the net. Then the net is retrieved and put on board the fishing vessel, and by the end the fishermen use a large scoop to take all the different fish on the deck of the fishing vessel. On this deck the fishermen sort the different species, they keep the tunas, and then they reject the non-wanted species that could be mahi-mahi, triggerfish or sharks. A classic FAD is usually a bamboo raft with all nets hanging underneath the FAD. As you can see, the problem is that these nets underwater can entangle animals, and this ghost fishing can cause a significant mortality of sharks. The idea is to reduce this mortality by designing FADs that will not entangle sharks or turtles. We have proposed different guidelines so that the fishermen could construct FADs that would respect the environment and would not catch any shark or turtles. Let's see now some images taken by observers on board tuna purseners. You can see that some animals, some sharks, some rays arrive alive on the deck. So the idea was to define some handling practices to release these animals in a very good condition and also in a safely manner so that there was no risk for the crew. While working on these best practices, we could also investigate the percentage of sharks that could be saved following these good practices. And we could see that we could save from 10 to 20% of sharks that are caught by fishing vessels by following these practices, which is already a significant reduction. However, we can see that we must find other methods prior to fish being taken on the deck of the fishing vessel if we want to reduce more the fishing-induced mortality of these sharks. We have developed different experiments trying to see if we could attract sharks away from the fad before the purseiner is setting its net. By putting a bait underneath a small vessel and drifting away from the fad, we could attract some sharks away from the fad. However, we have been doing the same experiment inside the net and trying to have the sharks escaping the net using this technique, and we didn't have very successful methods. From this knowledge, we think now that by making a small hole at this precise location of the net, we could find a method so that the sharks could escape through this hole while still having the tunas inside the net. This is the future experiments that we hope will be able to be investigated, in particular in this joint project funded by the ISSF. We have also investigated the behavior of different species around fads. One of the main bycatch species that we have been investigating around fads is the silky shark.
The major method that I use is using acoustic tagging, where we put an acoustic tag inside the body of the shark, and then we have an acoustic receiver that is attached to the drifting fad that drifts around the ocean, and then the shark spins around the drifting fad. And the data that the tag emits to the receiver, which is attached to the fad, is transferred via satellite to us, and then we can estimate the distance that the shark moves with the fad, how deep the shark swims under the fad, and if there is any pattern to the behavior that the shark shows when it's associated with the fad.
To complement this study, we have used pop-up archival tags. So some animals have been double tagged with acoustic tags and pop-up archival tags. And as you can see here, when these animals are tagged with two types of tags, we can obtain fine-scale behavior of the fad and then the large-scale movements when these animals leave the fad. This can give us very important results on the ecology of these animals. Tunas and sharks are not the only species living around fads, and we've been investigating these other finfish species.
There are about 20 species in general that are found on the fads, and we don't know much about these species, and some of them are being caught in relatively large amounts. Two of these species are the oceanic triggerfish and the rainbow runner, trying to find more about their ecology, to what degree they associate with the fad, the depth, segregation. So all this data, the bits and pieces that Made is putting together, will give us a better idea of the multi-species dynamics and the interaction between the species, which might be crucial in defining the dynamics of aggregation as a whole, affecting the target species, which are the tuna.
Some species make some excursions during the night, for instance, and only associate during the day. And this allowed us to investigate if there is a particular fishing time that could be done when tunas are present around the fad and bycatch species are absent. realized during the project how important it is to care about bycatch, and in particular sharks. And we have seen a big change of attitude by fishermen with these animals. And now they understand how important it is to work with them and to develop good techniques so that it's safe for the crew, because the fishermen are worried about the risk of handling sharks, and also what are the good handling practices to maximize the survival of sharks released by the personnel. The MADE project has provided important results on the ecology of bycatch species and also on the practices by the longline and the purse in fisheries. We have, for instance, now a set of different mitigation techniques that can reduce the bycatch by these two fisheries. Now, the research is not finished, but we think that by combining the efforts of scientists, fishermen and industry, we are not very far from having sustainable fisheries.